All right, so in this video, we're going to be reviewing for your midterm number 1. And this is a series of 4 videos, with this being the second video where we're going to go over chapter 2. So if you look at the review that Professor W gave you, there is a problem here where you have a data set of the number of minutes 20 internet subscribers spent during their most recent session, and then it gives you the data set, and I want you to construct the stem and leaf plot and then the condensed stem and leaf plot with the different groupings there. And I'm going to go ahead and show the answer just in case you don't have this with you, and you can do that problem on your own and then check your answers here. But a majority of what we're going to be doing in the video is actually working these textbook problems from chapter 2. Okay, and since these are all odd problems, you could find the answers in the back of the book. I found the answer keys for these ones actually not to be very complete, so I wanted to do videos on them so you guys get some support. So the first question here comes from question 2.3. Okay, and it didn't actually give a lot of context here. It just said, like, here's some data, and it was D, N's, and Y's. So I'm guessing it's probably like yes, no, or like don't know. Like those are probably the like response variables that could happen. And then part A wanted us to create a frequency table here. Okay, and so I'm getting a really bad glare from my window there, sorry. So frequency just means the number of times that this happens. So let's go through and count the number of times we get a Y. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. Let's count the number of N's there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 N's. And now let's count the number of D's. 1, 2, 3, and 4. Which brings us to our total here of 6 and 4 is 10, so 40. And that makes sense because I have 4 rows and 10 columns here. So that does check out that there's 40 data points, 40 responses. So my frequency should add to that. Okay. Now for relative frequency, you're going to want to take the frequency over the total. And I'm going to use an 84 to do that. I think that probably most of you guys use an 84. So that's what I'm going to use here for my technology. And so this relative frequency, again, is 23 over 40. So 23 over 40, and I get 0.575, which would be 57.5%. Okay. For the end, which I'm guessing is a no response, we'd have 0.325, which would be 32.5%. And then 4 out of 40, well, that's going to be 0.1, yeah, which is going to be 10%. And again, your relative frequencies should add up to 1.0. And your percents should add up to 100% if you were to total these. And that's how you can make sure you are doing what you're supposed to be doing here. Part C says, what's the proportion of yeses? Well, we can just use our diagram here to say 57.5. And then the next one says no or D. So I can just add these, which is one way to do this. Also, even though this isn't a chapter 2 topic, N or D would be the complement of Y, so it would be anything that's not Y. So you could also do like 1 minus the Y response, and you would be able to get the answer there because everything should add to 1 or 100. All right, part E and F of this question want me to make a pie chart and then the Pareto chart. So on the pie chart, I'm not going to worry about converting these to degrees or anything like that. What I'm going to do is I'm just going to use my percentages here to help guide me. So I know that yeses here, or Y, that response is 57.5%. Well, that would be a little more than half. So if I were to draw this line right here, I wouldn't want to dash this all the way down because that would be 50%. I want just a little bit more than 50%. Right? I want just a little bit more than half. Now, no needs to be about a third, and then D, it needs to be about 10. So I'm going to then divide this up. So this is no at 32.5%, and this is D at about 10%. Okay, and that's going to be my pie chart there. On my Pareto chart, remember that means that you're going to order these in biggest to least. You're going to have a bar for Y, a bar for N, and then a bar for D, and it has to go in that order. Now, since I need to go up to 58% and I'm looking at my scale here, I'm going to make each one of these worth 20% because I need to make sure that I have a bar high enough for that, and 60% would be high enough. So I could make a little halfy little tick mark if I wanted to for my 10s, and I'm going to make my Y bar, my N bar, and my D bar. And that is my Pareto chart. All right, the next question on the review that is suggested for you to go over is question 211, okay? And on question 211, it has this frequency chart that's given to you with the gallons of gas and the number of customers that bought that many gallons of gas. And the first question actually asks you how many people are in this data collection. And so we're going to just add up this column right here, 31, 78, 49. I know it's really hard to see. That glare is really causing some trouble here. 81, 117, and 13. So this is a total of 369 people. Okay. The next question, part B, says, what's the midpoint here? Well, the midpoint between 0 and 4 would be 2, and then 6, and then 10, and then 14, 18, and 22. And then it asks a question about what is the width of these, and is it equal width? And the answer is yes. Each bin has a width of 4 gallons. Okay, with the midpoint being then in the middle. Relative frequency, we're going to calculate just the same way we did in the other problem. So 31 out of 369 gives me 0.08. I'm just going to round to 2 decimal places and then have my percentage over here. Okay, I'm not going to worry too much about keeping a lot of decimal places because I have a lot of data. So 21%, 49 out of 369 gives me 13%. There, kind of helps with that right there. Okay, oh, but then we can't see the data. Okay. Okay, I'm going to round that up to 22%. 32%. And then 13 gives me about 4%. And again, you can check this because everything in the relative frequency should add to about 1.0, and everything in your percents should add to 100%. So you can check this like that, okay? All right, part D says, what's the probability, or what's the proportion? I'm gonna try to move this a little different. Sorry, so you can actually see this. Sorry, just give me 2 seconds. There we go. Move out of that glare spot. Okay. What's the proportion that are 12 or more? So one thing that's nice about this chart that we just spent all this time creating is you can just look at this 12 or more, and that is exactly the piece that we can just add together here. Because if it's 12 or more, then it's in this, or this category. So if I add 22% to 32 and 4, I get 58%. Okay, and then there was a question I just kind of abbreviated here, so it's not the best sentence, but why can we not determine the number of customers who purchase 10 gallons or less? And that's because 10 gallons is not an endpoint. And it is unknown the number between 8 and 10. Now what I mean by that is if you're looking at this category here, if you're looking at 8 to 12, that's where 10 is, right? That's where 10 gallons is right in here. I don't know how many people purchased between 8 and 10 gallons of gas. I know that 49 people purchased between 8 and 12, but I can't just split that in half. I can't just go into fourths and think that it is equal. You cannot do that. You have to keep the data as it is in that category. And so it is unknown how many people purchase gas between 8 and 10 gallons. So we are unable to determine a question like part E. Now on F, you want to do the cumulative frequencies here on part F. Okay, so the nice thing about the cumulative and the relative is everything on the first row is the same. And everything down here in the bottom for this last one should add up to your total piece here. Okay, now remember for the cumulative, it's that or less. So like the next one here, I do 31 plus 78 gives me 109. I add to get 29% here. Okay, and again, I'm adding everything that's at that one or less. So again, the next one, I'm going to take 109 and I'm going to add 49 to that. And so contextually what that does mean is if I wanted 12 or less, I could say 158 people bought 12 gallons or less. Okay, now if I add 13 here, that gives me 0.42 or 42%. Next one, I'm going to add 81. I'm going to add 22%. And then I need to add 117. Add 32. And it should make sense that if I then add that sorry, if you're like yelling it to me in your own while you're watching this, that should be 356. Sorry about that, 356. So that way now when I add 13, I should get the total 4%, everything checks out right here, which kind of just lets me know that I did the problem correctly to begin with, okay? All right, let's keep going with these review questions here. It looks like there are 2 more in this chapter. All right, for question 213, it gave this data table of 50 commuting times in the book, okay? And I know it's 50 because there's 10 columns, 5 rows, so n equals 50. Okay, now for my frequency here, I'm actually going to do a tally because I think that's going to be easier, and then I'll write the frequency off to the side. So 23, 44, 16, 18, 25, 17, 15, and 11, 22 and 36, 34, 22, 9, 29, 23, 26, 19, 24, 32, 39, 18, 28, 18, 30, 42. Halfway there. 33, 32, 26, 21, 46, another 46, 18, 31, 19, 29, 42, 39, 7, 14, 17, 12, 40, 30, 26, 24, 37, 48, 15, 37, 31. So it looks like our frequency is 2, 14, 14, 13, and 7. I'm just going to double check. Yep, that's equal to 50. And I add that all up. So that's perfect. So then when I do my relative frequency, 2 out of 50 gives me 4%, 0.04 and 4%. 14 out of 50 gives me 0.28. Now that's going to be the same here. So I'm just going to rewrite it. I don't have to recalculate that. It's the same thing. All right, 13 out of 50 gives me 0.26. And again, these are the percent conversions. And then 7 out of 50 gives me 0.14. Now on part C, it wants me to make a histogram. I need my scale here to go all the way up to 28%. So I need to go from 0 to 28%. What I'm going to do then is I'm going to go by tens. So this is 10%, this is 20%, and this is 30%. Okay, and then I'm going to make this a number line. So 10, 20, 30, 40, and 50. And this is times. Okay, so I only have 4% here. I guess I could have done it as a frequency. It doesn't matter. You end up getting the exact same shape. Okay, 28% for both of these. I'm going to make like a big bar, bring that down. 26%, and then 14%. Okay, and that is my histogram there. On part D, it says, what's the probability or what's the proportion of 30 or more? Well, I can just look here at my chart and get 40%. And then the last part of this question, which I just snuck up here, was part E. So the cumulative frequencies would be 2, adding on would be 16, adding on would be 30, 43, with my final of 50. Relative frequencies, 0.04, 0.32, 0.60, 0.86, and then 1.0. And then you can just change those to percentages if you would like. There. All right, our last problem that we're going to do is a stem and leaf plot here. Okay, and that's going to be for some completion times on a statistics exam. So the problem gave these 50 student times, again, n equals 50. Completion times for a statistics exam. Now, when I'm looking across the data here, the first 10s that I'm noticing are these two 20s here. So I have a 26, a 28, and a 27. So my first 10s is going to be a 2, and then it looks like it goes up to 7s here. So 2, 3, 4, 5, 6, 7. Now remember, even if you don't have something in that tens place, you still have to have this number line complete here. So let's say I didn't have any 40s. I can't just skip 4 here. I still need to have 2, 3. I would just have a 4 here, but then nothing in that row. 5, 6, 7. And then we need to make sure that we put these nice and in line. Okay. Now I'm going to grab just another sheet of paper, a little note card here, to list out all my 30s. So I have 37, 38, 38, 35, 39. Okay, so again, I want to make sure that I am putting these in numerical order. And any repeats, I'm going to keep that number there. Okay. All right, let's do 40s. So I have a 41, a 44, a 45, 49, 5, 42, 43, 44, another 43. I think that's it for my 40s. Okay, so it looks like I have 141. I have another 42. I have 2 43s, 2 44s, I have 2 45s, and 1 49. Okay, let's do our 50s. So 52, 58, 53, 53, 56, 50, 55, 52, 53, and 54. All right, so 50 is going to go first. No 51s, 2 52s. 3 53s. Now I'm going to stop here and I'm going to talk about 2 things real quick. One, notice that my ones places here, over here, so like this number is 27, right? 27, okay? And then I'm also making sure that all of these are going kind of like in a column so that you can see the frequency kind of within each little bar, okay? That's really important. So I have a 54, a 5, a 56, and a 58. Okay, so those are all my 50s. All right, let's do our 60s here. So 64, 66, 60, 67, 65, 69, 66, 65, 65, 4. Wow, lots of 60s, y'all. Okay. So let's now order these. 60, any 61s? No. 62s? No. 2 64s, 3 64s. So I'm going to put 4 twice so that I see that I have 3 64s. 1, 2, 3 65s. 2 66s, a 67, 2 68s, and a 69. All right, let's look at our 70s here. I have a 71, 72, 75, 74, a 70, 73, and 72. So 71, 2 72s, 3, 4, and 5. Now, essentially what we did is we just made a histogram almost exactly like we did here. What's difference between a histogram though and a stem and leaf plot is the stem and leaf plot, you actually keep the data values. Like if I didn't give you this data set now and I just gave you the stem and leaf plot, you could tell me in the 60s that 3 of those data values are 64 and 3 of those data values are 65. Whereas if I just give you this histogram, you can be like, there are some numbers in these here. And you can tell me how many there are in the percentage and the distribution that way, but you can't tell me the actual data values anymore. Whereas with a stem and leaf plot, you get to keep the actual data values here. Now, this problem wanted us to do all three of the stem and leaf type plots, okay? So I'm gonna grab just a blank piece of paper for us to add on to this here. Okay, so the first one would be a split plot. So if I wanted to split this plot, again, I don't need to even look at the original data set because I have all the data right here. If I wanted to split this plot, then I'm going to write my tens place twice. Okay, and 0 through 4, so 20 through 24 goes in this one. And then the 5 through 9, the other half of the data goes in the other one. Okay, now there's nothing in that first one, then I'm going to have 6, 7, 8. Now notice here, I don't have any numbers 30 through 34, so I actually will have nothing in this little bin here. Okay, so I'm going to have all of those numbers for the 30s go in that second stem. Now for the 40s, everything 0 through 4 goes in the first one, 5 through 9 in the second, everything 0 through 4 goes in the first one, 5 through 9 in the second, and so on and so forth and so on and so forth, and you keep doing this, and so that's going to be your split stem and leaf. Okay, now if we wanted to do a combined stem and leaf, okay, and I just want to double check here in the notes, she said to do it 1 through 3, 4 through 6, 7 through 9. Okay, so on the combined, now my tens place go here. Okay, now I didn't have any tens, so I'm going to put a star here to say no tens. I'm going to put my 20s, and then I'm going to put my 30s. And I'm going to make sure that I have that little star every single time, okay, to say like I have no tens. These are my 20s, these are my 30s, because this is the box here, the bin, sorry, for 1 through 3. Okay, I'm going to list out my 4s, and then in between my 4s, my 5s, and my 6s, again, I would have that little asterisk there. Okay, and then 7 would be the only one here. I do want to show you on the 7 one, you'd want to do 2 of these because there are no 8s and no 9s. Just like that. And then you'd have all the rest of this data here. So if you look like this big long leaf right here. Okay. And that is the review questions on chapter number 2.